We are going to continue our discussion today with the next subtopic, which is summary statistics by group. So before this, we only discussed all variables, and then we do not have any categorical variables yet in our explanation. But in data analysis, sometimes if they are categorical data analysis, we would like to compare the numerical measure. For example, we want to know the mean, the standard deviation by gender, instead of summarizing the mean and standard deviation for the whole data sets. So I'm going to use the dplyr package. So please check whether you do have dplyr package in your R. Okay, so I do not have any problem with that. So the data that I'm going to use today is empty cars. Okay, so before we proceed, first of all, I'm going to use lily.test. So this is actually an additional package. So if you do not have that, if you run for this one and you do not have lily.test, what you have to do is actually install the library notice. Okay, and then I'm going to run this one. So what I'm doing over here is I'm going to pipe in from empty cars. I'm going to filter only when the cylinder equals to 4. So that I'm going to only have cylinder equals to 4, and then I name the data set CYL4. Okay, so after that, I'm going to run lily.test. The lily.test actually return the D statistic, the test statistic, the difference between the empirical and theoretical CDR. And then we have the p-value. The p-value, actually we just need to know whether it is greater than 0.05. If it is greater, we fail to reject hash null, so that we can assume it to be normal. But then for this case, yes, we do get the value greater than 0.05, so our data is normal when the cylinder equals to 4. Alright, so now actually you can use a direct built-in Shapiro-Wilks test if you want to test for the normality. I'm going to show you. Okay, so for this case, you get the value where, so for our Shapiro-Wilks test, if you look at here, what we got is the test statistic equals to 0.91244, and then the p-value is also greater than 0.05. So our data can be considered as normal. So let's try to do, if we want to check all cylinders at once for 4, for 6, and for 8. Okay, so I already have this. So let's try to run this one, what we are going to get. So I'm going to make it better. So this is just an example. You can choose to run one by one. For example, the previous one is when only 4 cylinders, and then you run the Shapiro-Wilks, or you want to do it all at once for all groups of data. So you start by piping the data group by cylinder, and then what do you want to get? Okay, and then this is row wise from the data that we have ungrouped over here. We are going to mutate, and then we are going to develop the table, and then the table that we want is in the form of CYL W p value. So this is what happened when you run for this one. And then I do have another alternative if you want to use it, because if you do not want to use the row wise, because when you use the row wise, the player will handle each row independently. So right now we do have the alternative. So we need to use the package broom. Okay, let's try to install this one first. If you don't have it in your R, okay, I do have it. Okay, let's try to run this, and I'm going to explain what happened. Okay, so right now we do have almost the same actually, but then much more simpler. So what we are doing is group by CYL. Again, it is the same. We are going to group the data based on the cylinder, the number of cylinder. What we have is 4, 6, or 8. And then after that, inside the function, the summarize, we are telling R to tidy the Shapiro test, the results we want it to be tidy. And then I forgot to mention before this, we are calculating for the mpg miles per gallon. And then again, tidy is the function from brooms. We are telling R to clean the data frame with standard column names. So what we have over here is CYL for cylinder, and then we do have the statistic value, and then we have the p value for each. All right. And then the last one, the select, this is actually what we want to do is keeps only the key columns you want. So you want to get the CYL, you want to get the statistic, the Shapiro Weeks W, and then we want to get the p value for deciding the normality. And then we want to remove the extra column, because actually if you don't choose these three, we are going to have the methods, the data.name, all etc. that you don't really need to know actually. So this is much more shorter for the example, the previous one. So you can choose any method that you want. Okay, so we are going to continue with the summarizing our categorical data. So first of all, um, we have to get the frequency counts for our categorical data. So in R, actually, we do have the table function. So let's try to do table to tabulate our categorical data. For this one, I'm going to use the penguin species. So that's for tabulate. So we are going to use function table. Okay. So this is actually to tabulate our categorical data. So let's try to run for this one. Oh, okay. If you do not have the penguin, please check your library. So run. Okay. So I'm going to develop a table using table function. So let's see our data. Yeah, it's totally different. So if you cannot imagine the actual data set, you can actually view your data. Okay. So when you view your data, this is your data. So if you want to get the value, actually, it is quite difficult. Yeah, you are going to get the frequency, but then not in the form of table. So I will show you what happens if you just call the data and then the variable. Show this to you what happened when we just call the data. So this is what you get. It is not really helpful actually. So that's why we need to use the table function. So if you use the table function, you will get much more better information lah. So for the elderly type of penguin, we do know that we have 152. For Jantu, 124. So first of all, if you want to do summarization for categorical data, you can use function table. And then the next one, what we got is if you want to check for the proportion and percentages. So this is, it depends on what do you want to do. So let's say right now we do have the frequency, but we are interested to know the proportion or the percentages so that we have clear understanding of the whole data set. So what we can do, we can use the proportion or the prop.table and then from the table. Okay. So actually, if you do not want to do this, we can just save the data. I save it into A so that our coding will be much more simpler. So after you save it in A, and then this would be A. This is optional, depends on you. If you want your codes to be simpler, you can do this. So let's see. So when I get prop.table, so what do you get is the proportion. So if you want to see the different whether you save this one or do not save this one. Let's see. Let's run for the. So yes, you do get the same values. So it depends on you what you want to do. You want to save it as a data or as a value. You can see it over here actually. I save it as A. So A is a table, so it is not a data set. This is just a value. So you can clean your environment anytime. There's nothing. So that's an option to you. So the next one, what we want to do is if you want to combine the frequency value and the percentage together. So, okay. So let's say before this, what you get is value. So our table is value. So what am I doing right now? I'm going to save it as data frame and I'm going to name it as frequency 1. So let's try to do this. All right, let's check your environment. So yes, currently it is saved as data. So totally different compared to before. So after that, I want to get the proportion. So I'm going to use the prop.table for the same value. But then if you notice the previous one, the value is in decimal. So I want it to be in percentage. I will multiply it with 100. So save it as data frame, name as percent 1. So I'm going to run this one. Check our environment. Yes, we do have the data. So if you click it, this is your value actually. All right. And then the next one, so what I'm going to do, so if you don't remember what happened when I clicked the value just now, all right. So what I'm going to do is I'm going to rename the data. So I'm going to rename the column. So the previous one, we do not have it as percentage. So right now we get the value as percentage. Okay, so next I want to combine the first table, the frequency one, and the percent one. All right, so C bind. So this is column bind. So let's try to do this. So this is what you get. So the next one, let's do the cross-tabulation. So for cross-tabulation, when you have two or more categorical variable, and then we want to observe the relationship between them. So let's try to do this. Okay, so we are going to make a table, but then for this one, actually, we have the species, and then we want to get the island. So look at this. This is our cross-tabulation table. So it is very useful if you want to see. So based on the cross-tabulation table, you can see that on the island, Dream Island, there's no, on the Dream Island, there's no Gentoo. And on the Togerson Island, there's only Adley. And actually, I think this one will be the largest island because you have two types of penguins on the island. So, yeah, we do know the relationship actually. So it is very clear the penguin have preference which island they want to go. It's very useful actually. So there are several useful packages for categorical data. You can go to our notes and try it yourself. So that's all for our categorical data summarizations.